Hi, I'm Rajlakshmi, working as an assistant professor in the Department of ECE at R.M.K College of Engineering and Technology. This video is all about embedded system design process. Before entering into the design process, let me tell you what is process. So process is a series of actions or steps that are taken in order to achieve a particular thing. So what are the importance of design process? So the design process allows us to keep a scorecard on a design to ensure that we have done everything we need to do. So it allows us to develop computer aided design tools. It makes easier for members of a design team to communicate. Hi, I'm Rajlakshmi, working as an assistant professor in the Department of Electronics and Communication Engineering at R.M.K College of Engineering and Technology. This video is all about embedded system design process. Before entering into the embedded system design process, let me tell what is process. Process is a series of actions or steps followed to achieve a particular thing. Now, looking into the importance of design process, the first thing is that it allows us to have a scorecard on the design so that we can ensure that we have done everything we need to do. The next thing is that it allows us to develop computer-aided design tools. The design process makes it easier for the member of a design team to communicate. The next thing is what are the main goals of the design? The first and the main goal of the design is to create a product that does something useful. The other goals that are to be considered during the design are functionality, manufacturing cost, power consumption, performance, time to market, and quality. Now, looking into the steps involved in the embedded system design process, the first step is requirement, the second step is specification, followed by we have architecture, the next step is components, and the last step is system integration. We have two approaches. One is top-down approach in which the design will be from requirement to system integration, which will begin with the most abstract description of the system and conclude with concrete details. The next one is the bottom-up approach in which we will start the design with components to build a system. That is the reverse manner of top-down approach. So what is requirement? So requirement is the informal information that is collected from the customer in the plain language description, which is nothing but what the user wants and expects to get. So how this requirement is collected? So the requirement can be collected by talking directly to the customer or talking to the marketing representatives or by providing prototypes to users for comment. The requirement can be functional or non-functional. The functional requirement captures the basic functions of the system, whereas the non-functional requirement includes performance, cost, physical size, weight, and power consumption. The important thing that we have under requirement is requirement form. It is filled at the start of the project and it can be used as a checklist in considering the basic characteristics of the system. The requirement form consists of the below mentioned fields. The first field is the name, which gives name to the project. The next field is purpose, which gives a brief description of what the system is supposed to do. Next comes the inputs and outputs of the system, which comprises the types of data used, the characteristics of data used, and the types of I/O devices. The detailed description of what the system does will be given in the functions field. The performance field talks about the performance of the design. The next field shows the manufacturing cost, power consumption, and the last field gives the physical size and weight of the design. So I have taken GPS moving map as an example. GPS moving map is a handheld device that is used to determine the user's current position and displays it on map data from the device internal storage or from the internet in real time. The requirement analysis of the GPS moving map is done here. The name for the design is given as GPS moving map. The purpose of this design is to be used for diving purpose. The power button, control buttons are the inputs. LCD display is the output. The functions of the design is that it always displays current, latitude and longitude. The performance that the device updates screen within 0.25 seconds upon movement. The manufacturing cost is around $40. Power consumption is 100 milliwatt. The size of the device is 2" cross 6" and it weighs around 12 ounces. The second step in the embedded system design process is specification. The requirements are refined into specifications. The specification is more precise description of the system which serves as a contract between the requirement and the architectural design, and it provides input to the architecture design process. Our specification of the GPS map would include several components, which includes the data received from the GPS satellite, the map data, the user interface, the operations that are performed to satisfy customer requests, the background actions required to keep the system running. The architecture design describes how the system implements the required functions. Specification tells what the system does, but architecture tells how the system does things. This architectural design gives overall structure of the system. The architecture of the GPS moving map is shown in the diagram. The diagram is in the form of block diagram that shows major operations and data flows. So this diagram is still quite abstract. It tells the overall operation, that is, the user's current location is identified by the data collected from the GPS receiver. Map data will be collected from the device internal database, and to render that is to draw the results for display. It doesn't tell what operations will be performed by the software running on the CPU and what will be done by the special purpose hardware. The overall functions of the moving map device is separated so that we can potentially do them in parallel. This is searching the data is one part and performing the rendering is other part. This is the refined diagram, one for hardware and another for software. The hardware block diagram shows that we have CPU surrounded by memory and I/O devices. The software block diagram closely follows the system block diagram but added a timer to control when the buttons can be read on the user interface and rendered the data onto the screen. The next step in the design process is component design. The designer may use ready-made components, or the components may be modified from the existing designs, or the designer may start the design from the scratch. Coming to the GPS example, the standard hardware components include CPU and memory chips, and the standard software components is the topographic database. The final step in the design process is system integration, which is putting together the components. This is the stage where many bugs will appear, so the individual components should be tested first. So that's all about the embedded system design process. Thank you.